In this video, we will talk about how you can go about calculating heat. Heat can be calculated using the equation Q equals mc delta T, where Q is the heat, m is the mass, C is the specific heat capacity, and delta T is the change in temperature. Let's think about what the specific heat capacity is saying. Its units are joules over grams times Celsius. That is, the specific heat capacity is the amount of energy it requires to raise a certain mass of something a certain number of degrees. Let's consider some specific examples. Let's take the specific heat of water, which is 4.18 joules per gram Celsius. That means that 1 gram of water takes 4.18 joules to raise it by 1 degree Celsius. Let's compare the specific heat of water to something else, such as silver. The specific heat capacity of silver is 0.233 joules per gram Celsius at room temperature. Notice the difference in values between silver and water. Water has a very high specific heat capacity. But what do these two values mean? Water takes more energy to heat up than silver takes to heat up. Let's think about a boiling pot of water, for example. And let's suppose you had a metal spoon here that was made out of silver. From experience, we know that water takes a considerable amount of time to heat up. But if you add a spoon inside the pot of water, you'll notice that the spoon heats up relatively fast. Why is that? That is because water has a relatively high specific heat capacity, and silver has a relatively low specific heat capacity. That is, water takes a lot more energy to heat up than silver takes to heat up, which is why the spoon would probably heat up much faster than the water would take to heat up. Let's go back to our original equation, Q equals mc delta T, and check the units to make sure that this equation is plausible. We know that heat, Q, is written in terms of joules, M is written in terms of grams, C is joules per gram Celsius, and the temperature would be expressed in terms of degrees Celsius. We see that Celsius cancel and grams cancel, and ultimately we're left with joules equals joules. So we know that this equation at least makes sense.